The National Aeronautics and Space Administration presents Aeronautics and Space Report.
Sometime in the future, American astronauts will explore the moon. Then take off from the lunar surface and return to Earth. For the machines which will do the job, a series of intense fabrication and tests. Here, the beginnings of the ascent stage propellant tanks for the lunar module. When completed and installed, they will be used to store and feed tons of liquid fuel to the main engine as it lifts off the moon. Because of the critical role they play in the Apollo mission, their chance of failure must be less than 2 in a million. Made by the Aerojet General Corporation, the tanks are put through 34 major shop operations. The 2 half shells are machined from 1 1/2 inch thick rough forgings down to 35 thousandths of an inch, thinner than a dime. After machining, the tank halves are welded together automatically in a special vacuum chamber. The sphere is then submitted to temperatures up to 950 degrees in an electric furnace to relieve stresses in the metal built up during machining and welding. Samples of titanium alloy, of which the tanks are made, are also heated and later stretched to the breaking point to make sure the tank's physical properties meet specifications. To ensure an instant start of the spacecraft's engine under the moon's zero or low gravity conditions, a special screen is machined to trap small amounts of fuel. 2,300 holes, about the size of a pinhead, are drilled to make the screen. This is a centrifuge. Earlier qualification models of the tank were whirled up to 14 Gs, 14 times the force of gravity, simulating the worst possible conditions the lunar module might encounter on its trip to and from the moon. One of the final steps is a thorough cleaning in an atmosphere-controlled clean room. Contamination levels must be within certain limits. To make sure, residue left over after the cleaning is noted for size and the number of particles actually counted under a microscope. Checks for leaks, vibration tests, these and many more go into the 16 weeks it takes to produce one of these spheres. Fabrication, qualification, testing, reliability, a necessity when second best is not good enough. In aeronautics, NASA is continuing to seek an all-weather landing system for helicopters and the new vertical and short landing craft. At Langley Research Center in Virginia, test pilots are carrying out blind landing studies, testing out new instrumentation and displays. To simulate blind landing conditions, the left seat is shielded with amber plastic. When combined with a blue visor, the pilot is unable to see outside the cockpit. Ground-based radar and computers provide signals to the airborne instruments and make them operate. These include air and ground speed, range, height, and vertical speed indicators. Right now, helicopters and even commercial airlines cannot land their craft if there's a cloud ceiling lower than 200 feet. Using these experimental displays, the test pilots were able to narrow this distance down to 50 feet. Significant research toward the day when all aircraft can land under zero visibility conditions.
This has been an Aeronautics and Space Report presented by NASA, the National Aeronautics and Space Administration.